this video, we're going to prove the following fact. Let G be a group and consider the mappings of G into itself, denoted by lambda sub G, defined for all G by X operated on by lambda sub G is G sub X, or G times X, for all X in G. That is, it's just left multiplication on by G. We want to show that each lambda sub G is 1 to 1 and on to, and that lambda sub GH is the same as lambda sub G, sub H, times lambda sub G. If you like watching mathematical proofs, possibly like the one I'm about to give, subscribe to my channel, as this is all we do on this channel. So I want to show that lambda sub G is 1 to 1. So suppose what you normally suppose to show 1 to 1-ness. Suppose that X lambda sub G is equal to Y times lambda sub G. But that's the same as, like I said, multiplying by G on the left. You get Gx equals Gy. But G is a group, and let's formally say it. Let X, Y be in G. Well, groups have the cancellation law. That is, I can cancel out G. Well, that implies X is 1 to 1, which implies lambda sub G is 1 to 1. Now we go to onto. Let Y be in G. Now, you want to compose lambda sub G with something, and you want to get back Y. So let's see. This is going to be G times the something. These two are the same. And you want to get Y. Well, let's see what's going on. You have G, you don't want G, you want Y. So you multiply by G inverse, so now you have the identity element. And if you multiply their identity element by Y, you'll get Y. So there it is. G inverse Y, when lambda G maps that, it will map it to Y. So this implies that lambda sub G is onto. Now let's go on to show the last part of this proof. Let X be in the group G, and let's see what lambda GH does to this. Well, like always, it multiplies on the left of X, in this case X. So is GX times X, GH times X. But that's G times HX. Ooh, I'm multiplying on the left by H. So this is G times, or G composed with X lambda H, because I multiplied on the left of X by H. That's what it says here. Well, now, this is just, something's bothering here. This should be an equal sign right there. Now, this is just some element in G. There it is. This is some element in G. I can even tell you what element it is. It's HX. And is being left multiplied by G. Well, I can write that this way. Now, this here, let me just move it over a little bit. Oops. So, let's just get rid of it and move it over a little bit. So this becomes X x lambda h lambda g, lambda sub g, but this is x times, or x composed by lambda h lambda g. So let's see what we have. Just want it to be nice and clean. This is x lambda gh. So we have this equaling to this. That implies that the mappings, they did the same to x, so the mappings are equal to one another. Lambda sub gh is the same as lambda h times lambda g. And that's what I wanted to prove. In fact, it's the last thing that I was asked to prove, and that means that the proof is done. If you like watching math proofs like this, subscribe to my channel. Please click the like button. Tell your family and friends and definitely enemies about my channel. See you guys in the next video, I hope. Thanks for watching till the very end. Watch and learn.